that music inside this hall, right? So how it will do? It will play the music continuously, no? Right? It will read the byte and it will out that one to DAC, and continuously it will do at typical bit rate. It will keep on outing, right? Say here 8085 reading one byte of your say MP3 file, then it is outing that one to a port where DAC is connected, and DAC output is given to amplifier, then it is given to a speaker, right? So microprocessor is continuously playing music, right? During this period, what will happen? People may enter through this gate by pushing this, right? So if this door opens and a person enters, that time, say RST 5.5 interrupt is generated, right? So microprocessor will stop playing music, and then it will go for counting how many person has entered over here, right? Now if some person is listening music for says so much time and he gets bored, then what will happen? He may exit from here, right? So when a person exits from here, then it generates RST 6.5. So 8085 will again stop playing music, then it will go for decrementing the count, so that how many persons are inside this hall can be counted, and if a number of persons are more than 99, then it will glow an LED, right? It will glow an LED by sending 5 volt to SOD pin, no? I said 5 volt to SOD pin, so that LED will glow. LED will glow, and then this entry door will be closed. It's like houseful, right? Now there may be the cases when a people is entering, one person is entering over here at same time, right? A person may be going out from this exit door, right? So both interrupt will be generated simultaneously. So what exactly then processor will do? Hello?
Sir, it will consider the interrupt 6.5, RST 6.5 first, then RST 5.5.
So first of all, it will decrement the count, then it will go for RST 5.5, then it will increment the count. Okay. So here you can see priority is there, right? Now I said that processor will stop playing the music and it will service this service routine. But this will be done at very, very fast rate. You won't be able to, this will be done within millisecond, right? Within 10 millisecond, counting of person will be incremented. Similarly, it will be decremented. And within 10 millisecond, if it is done, so if processor is stop playing for say 10 millisecond, if processor is stopping playing music for 10 millisecond, he won't be able to notice whether music was off or not, right? It is processor is very, very fast. Anyway, so how to write the program for this, right? What was the problem statement? We have to count number of person inside the hall, glow a red LED connected to SOD pin if count is greater than 99. Okay. So let us start writing the program. So first of all, you need to remember this control word or sim word, right? First one is SOD, next one is SDE, serial data enable, or SOE, serial output enable, right? Third bit is don't care, then R7.5, then we have MSC, then we have M7.5, then we have M6.5, then we have M5.5. So we have to enable these two. So these two 6.5 and 5.5 interrupt we have to enable. So we have to put these two bits 0. Okay. RST 7.5 we are not using, so we need to mask this. Right. This 8085 should not respond to this. Then in order to enable all these 3 bits, to make active all these 3 bits, M7.5, 6.5 or M5, M5.5, you have to make MSB bit 1, MSC bit 1. Since this is marked, so whether you put 0 over here and 1 over here, there won't be any change. So let us make it 0. Let us make it 0. We do not want anything to be outed at SOD pin. Otherwise, what will happen? Our red LED is going to glow. So we should not out anything. So we need to put this SOE bit 0. You can put this one 1 or 0, no matter. Right? So let us, in last example, we took this one SOD as 1, right? So again, we will put this one 1. So, but this SOE bit is 0, so nothing will be outed. So first instruction will be what? What will be the first instruction? This is 8 and this is C. MVIA 8CH SIM EI. This will be our instruction. This is for setting the interrupt mask. No? Right. So whenever M6.5 RST 6.5 interrupt comes at this pin, right, processor will branch to ISR of RST 6.5, and here it will decrement the count, right? Similarly, if RST 5.5 comes, then processor will branch to ISR of RST 5.5 and count will be incremented. Okay. So let us put the count value in register C, MVIC 00H. Right. Now processor can play the music file. Right. How it will do? Right. It will do LDA first byte, out first byte. Then it will do LDA second byte. Then it will do out second byte. Continuously it will do. Or you can have like this. LXIH file address. Okay. Let us put the memory location. Say 2 2400H, move A comma M. It is reading first byte at 2400. Then it is doing this. Say D at say 2500H. 2500H. INXH, INXD. Sorry. Move A comma M, stacks D. Right. So it is reading data from 2400H and it is outing that data to 2500H. And this you are doing repeated. So JM INX we should not do. Right. Anyway, so then INX H, INX D, right? DCR, एक byte count, JNZ, repeat will be here, right? And after outing, say these many bytes, right? Once again it will repeat JMP again. So again will be over here. And here it is halt. So first of all, microprocessor is setting interrupt mask, setting the count value to 00H. Now it is playing, it is doing something, some job continuously, right? Some job it is doing continuously, like playing music, right? Now it has to count the number of person entering into a hall. So how it will do? Moment a person enters over here, RST 5.5 is generated. So what will happen? Processor will branch from main program to ISR, new slide. So of course we know what will be the branched location for RST 5.5. It will be 002CH. Right, and here you will find C3 00 say 90 RAM location will be given. So your ISR should be written over here. RST 5.5 vector location is this, right? So from main program, from this main program over here, processor will branch to this location. And from here it will jump to RAM location. Here you have to increment the count. So only thing you have to do what? INR C. So C will become 01. Right. Then it will return to main program, RET. Next, suppose a person exits from the hall. Then processor will branch to 0034H. Now, this is for RST 6.5, 0034. So here, suppose it is C3, 00A0 is written. So from here it will branch to A000H. Right. Here it will do DCRC and then it will return to main program. Okay. Now, whenever processor branches to ISR, it generates INTA bar signal, interrupt acknowledge signal. What is the use of this interrupt acknowledge signal? When processor is interrupted through INTR pin, which is non-vectored, that time INTA bar is generated and it gets the vectored location from the interrupting device. Right? ISR location it gets from the interrupting device or interrupt controller. So one use of INTA signal is this. Second use, whenever processor branches to ISR of a hardware interrupt, it generates INTA bar so that all interrupts except trap are disabled. Right? Suppose processor has branched to over here. Processor has branched over here. Right? And when it is branching to this location, that time if any interrupt comes, which is a RST 6.5, which has got highest priority than RST 5.5. So what it will do? When processor is branching over here, RST 5.5 has come, processor is branching to service routine C30090. So from here it will jump to 009000. So during this, suppose RST 6.5 comes, a person exits. What processor will do? Count has not incremented. Right? RST 5.5 has come, so processor is branching for incrementing the count. But when it is branching for implementing the count, that time RST 6.5 has come, means one person has exist. Means one person has come out from the hall. So what will happen? Of course, if RST 6.5 is not disabled, processor will branch to over here and it will decrement the count. And incrementing count will be skipped. Right? So whenever processor branches to ISR, right, before branching to ISR, it disables all other interrupts. Right? So finally, before returning to main program, you need to enable all the interrupts. Then you have to return. Okay? Hello? Are you following?
Yes, sir.
Right. So similarly, here also you have to do EI and return. Otherwise, all interrupt will be disabled. Now, if persons are right, when one person enters over here, right, RST 5.5 is generated, processor branches to ISR, and before branching to ISR, INTA bar is generated. It disables all the interrupts. If any, right, it disables all the interrupt so that counting of person will be done first. Right? Counting of person will be done first, and when it returns to main program, that time it will be enabled. So what will happen? If a RST 5.5 has come, right, it is branching to, it disables all the interrupt, then it branches over here. Now when it is branching over here, RST 6.5 also arrives. what will happen? It will go in pending interrupt, right? And first of all, it will increment the count, then it will return to main program. Increment the count, it will enable all the interrupts, and when it will return to main program, it will see RST 6.5 is pending. So again, it will come to RST 6.5 subroutine, and here it will come, it will decrement the count, and before coming to this, again interrupts will be disabled. So again you have to enable it, then you return to main program like this. Now in this case, that priority is not clear. No, if RST 6.5 or 5.5 has come, but RST 6.5 has 5.5 has come, right? Processor disables all the interrupt and branches to ISR of RST 6.5, right? In between, suppose during this processor is branching to ISR of RST 6.5, that time if high priority interrupt comes, since it is already disabled, so it won't be recognized, it won't branch to its ISR, it will be kept in pending interrupt. So when it will return from main program ISR to main program, then it will service that. Right. Now, suppose if you do this, if you do this EI over here, EI over here, INRC, INRC, and here it is RET. What will happen? If RST 6.5.5 has come, right, processor will branch to ISR of this, but before branching, it will disable all the interrupts by generating INDA bar signal. But when it goes to ISR of RST 6.5.5, first instruction is what? It enables all the interrupt. So what will happen? After this, it will branch to ISR of RST 6.5. It will decrement this, then it will return to over here. And from here, it will return to main program. Hello?
Yes, sir.
Yes, sir.
Now it is clear, no? What is priority? And
Yes.
if you do not want this, then simply we can go over here. INRC, EI, and return. Now, if say RST 5.5 and 6.5 comes simultaneously at a time, so what will happen? RST 5.5 will be pending. Then first of all, RST 6.5 will be served, count will be decremented, then it will come back to over here, and then count will be incremented. Okay. Now, after incrementing the count, you need to check what? You have to check that count is INRC move A comma C CPI what? कितना से कंपेयर करना है जी? कितना होगा यहाँ पे? I said 99% over here inside the hall. If it is greater than 99, then we have to send 5 volt to LED, this SOD pin. So what we have to do over here? CPI, if C is greater than 99, 99 it is in what? Decimal. So what should we write over here? Hello?
Sir,
CPI?
64.
Huh?
64.
CPI 64H. JC. J and C has to be there, no? If
Yes.
carry flag is there, it means if carry flag is there, it means A is less than 64. Is it not? 64.
60.
A is less than 64H. J and C. J and C. What? It has to continue with the process. And if carry is there, oh sorry, CPI 64H. So if carry flag is generated, CY equal to 1, it means A is less than 64H. So it has to continue, right?
Sir,
So,
excuse me, sir.
huh,
Sir, we need to do a XRA A, no, sir, after remove A, comma C to clear the carry flag before.
no. In fact, we want to check the carry flag when we do, say, CPI 64H, right? Accumulator content will be compared with 64H. Now, if A is greater than or equal to 64, carry flag won't be there, right? So, and if carry flag A is greater than or equal to 64, then carry flag won't be there, no? So J and C red LED. Red LED, right? Or you can have this JC continue. JC continue, right? Else you have to glow the red LED. So MVIA C0H SIM RET return. So red LED will glow and it will return without enabling the interrupts. So red LED will glow and nobody will be entering into the hall, right? Otherwise, it will continue. Continue means it will enable the interrupt and then it will return. And A .000, here it will be DCRC EI RET. Hello. Hello. Is this okay?
Yes, sir.
Now I will take another example. Suppose in a car, right? We have two sensors, right? First sensor is rain sensor, right? Moment say rain starts, right? Right on this what windshield, that front side, right? Raindrops will start falling, right? So sensor output is going to be like this, spikes, right? And we have to interrupt the processor. Rain sensor will interrupt the processor using RST 7.5. Right. We have another sensor, seat belt sensor. Right. If a driver takes this driving seat, and if he doesn't say uh, uh, seat belt has to be on after that, and if driver forgets to do that, then alarm has to be generated, right? So moment a driver takes its seat and he is about to he just forgets the seat belt, taking the seat belt, that time that sensor will generate alarm, right? So of course moment a person sits or in the driving seat, right, a pressure sensor will be sensing that, and it will generate continuously 5 volt like this. So you can use either RST 5.5 or 6.5 for that purpose. And of course door sensor also will be there. If engine is running, if someone starts the car and if door is not properly closed, then also alarm is generated. So for that we will have, say, door sensor. Okay, if any door is not closed, all door has to be closed properly, otherwise RST 6.5 will be generated. If seat belt is not taken properly, then RST 5.5. And if rain sensor comes, if rain starts falling, right, then what type of service routine has to be there? It has to run wiper, no? Run wiper motor. It will run wiper motor. And when should we start this wiper motor? Moment, say, first drop falls on the windscreen, or we take some time so that, right, so that wiper start wiping the screen when some amount of, say, a heavy amount of rain is there. Otherwise, on, say, सूखा हुआ जो ये है उस पे चलाने से तो अननेसेसरली का वो धूल के साथ ये होगा ना. So we need to give some time so that sufficient amount of water is there in the wind. Then we have to start this. So all three interrupts we have to use, right? And for turning on the wiper motor, SOD pin has to be like this, for say, but this SOD pin has to be made 0 for, say, 10 seconds. Then it has to be made 1 off like this. This pulse will start the wiper motor, right? But this pulse has to wait for 10 seconds so that sufficient amount of water will be there on the wind screen. Then wiper starts and it cleans the wind screen. Okay, winds, what we call windshield, no? Anyway, so SOD pin has to be 1, 0. It has to be 0 for 10 seconds. So it will wait for 10 seconds first. Then it will generate this pulse of, say, 2 milliseconds. This 2 millisecond pulse will turn on the motor and it will start wiping continuously. So I'll take this sim control word. Easy. Copy image, new slide, delete, Control V. So we have to make this one 0, this one 0, this one 0. All these 3 bits has to be 0 because all 3 interrupts we have to use. Next, for using RST 7.5, then if you put this one, then also RST 7.5 won't be recognized. You can see over here it is written reset RST 7.5. If RST 7.5 is equal to 1, RST 7.5 is not allowed. If RST 7.5 is 0, then RST 7.5 is allowed. Okay. So this bit also should be 0. Right. Either you make this one 1 or make this one 1. It's going to do the same job. So in order to activate RST 7.5, both has to be 0. And in order to activate these 3 bits, MSC has to be 1. Nothing we want to out at SOD pin right now, so both has to be 0. This is, don't care whether you make this one 1 or 0, it's not going to have any effect on the interrupt structure or even at serial output pin. So let us make it 1. So what is our control word? Anyone quickly? Hello?
Sir, 28.
It is 28. So MBI A 28H SIM PI has to be there. Right? Now, processor is doing your main program continuously. And finally, it is halting over here. Hello? कौन? हाँ हाँ विमल. अच्छा. हाँ 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 हाँ. नहीं 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 नहीं. You meet Dr. Vinath regarding this, so he will tell you. Right? Or okay, so after say around 10:15, you come to instrumentation lab, which is at the corner now. Right, instrumentation lab. I'm taking say microprocessor class right now. So around 10:05, you come over here. I will give you, no problem. So suppose a driver is sitting on driving seat and he has not taken the seat belt properly. Then RST 6.5 or 5.5 will come, interrupt will be generated, and processor will generate an alarm, right? Beep sound. So how it will generate alarm? By outing something at say some port, right? So seat belt sensor, if gives you the alarm, right? So processor has to out FFH at port 07H. Suppose port address is this. So this FFH has to be put on this port so that a beep sound will come and driver will be alert to take the seat belt, right? If door sensor, if any of the door is not closed properly, then 6.5 will come. And same alarm it has to generate. So again, out FFH at port 07H. Right? Suppose if door is open and key is inside the ignition key, key is in the say in the ignition hole, then also alarm may be generated. Then we don't have all these features because one is for say seat belt, another one is for say checking the doors, right? Then for checking other parameter, tire pressure, right? Then say if speed is more than rated one, then also alarm may be generated. So in that case, you will have to use other interrupt features, no? Using INTR, you have to interrupt the processor. So anyway, so for these two, and for running the wiper motor, you have to wait for 10 seconds first. Then you have to generate the pulse of 2 millisecond duration. Control Z. Right. So now I should not write the vector location. I will simply write ISR 6.5 like this. MVIA FFH out 07H EI return. Similarly, ISR 5.5, right? MVIA FFH out 07H EI return will be the ISR. But ISR of 7.5 क्या करना है? MVIA C0H SIM. Now 40H 0 you have to move, no? 40H SIM call delay 10 second. Then MVIA C0H SIM, right? So for 10 second it will be 0, then it will become 1. Call delay of 2 millisecond, right? So for 2 millisecond it will be 1. Then MVIA 40H SIM, right? EI RET. This will be the case. Avik Sen. Oh, Abhishek Agrawal, you promised, no? You will study more now. Hello. Okay, in second quiz, all these things will be there, right? Anyway, I'll put another example over here, then I will leave, right?
Sir, excuse me, sir.
Yes.
Sir, please could you keep it in next class, sir? We have a class now.
Why not? Right. Next class we will discuss coffee machine control using 8085. Okay, so I am stopping this over here. Everything is recorded. So if you wish, you can go through the recording. Right. Okay. Stop.
Thank you, sir.